Hi everyone, and welcome to our quickest ever theory video this year. This is graphing derivatives. Now the reason it's going to be so quick is that all of these skills we've actually done before. And this will just be bringing them all together really. So we've been given a cubic function there, and I've just took a screenshot of my graphics calculator showing you the graph of the cubic function. And we're going to try and graph the derivative. So first of all, we have to find the derivative. So we're going to find f dash x using rule, unless you really love first principles, but I doubt it. And that's our derivative there. Okay, we're now going to try and graph that derivative, and we've done this before to death in quadratic, sorry, and then again in mid-years. So we need to find the x-intercepts and the y-intercept. So y-intercept's pretty easy. Y-intercept occurs when x equals 0. So we know our y-intercept is at negative 15. X-intercepts are a little trickier. We have to factorize. So our highest common factor first, then simple factorization, AC method, completing the square. What else do we know how to do? Quadratic formula. Okay, we've got a lot of methods there. So I'm going to take the highest common factor out first, which I can see there is 3. Okay, and then I'm just going to be able to do simple factorization. So 2 factors of negative 5 that add up to negative 4. So negative 5 and 1. Okay, so what's going to happen is we are going to have x-intercepts at 5 and at negative 1. Now, it's really hard to see here, but I'll show you on here. So I'm just going to find the turning points. This is the original function. So analysis G solve for anything, we're going to go the maximum. So the maximum is at negative 1, 8. And the minimum is at 5, negative 100. Can you see the relationship between those two? So here, these two x-intercepts for the derivative are actually the stationary points for the function. So if we've got a stationary point there, that's pretty rough, then we'll have an x-intercept there. Stationary point there, x-intercept there. It's a positive quadratic, so it's going to look like that. Okay, so if you take anything from this video, the stationary points turn into the x-intercepts and vice versa. So if you're given a derivative, let's say this, that's your derivative, you're going to have a stationary point somewhere along here and a stationary point somewhere along there. Okay. You won't have to go the other way, I don't believe, that often, but we might make you do it just for fun anyway. But we need to make sure that you can still graph quadratics, and this is really good practice for your exam as well. So the worksheet's there. I told you it would be a quick video. Work your way through the worksheet and check your answers using your calculators. Okay, so I just showed you how to do that quickly. You type it in, analysis, G solve. You can find the max, the minimum, the y-intercept. And if you want to graph the derivative in there, so you could put the derivative, 3x squared minus 12x minus 15, you could put that in there, graph them both together and make sure it looks the same as your diagram. Okay, that's it.